Now let's look at the next example problem, print hexagon. So this is a problem statement. Essentially, we want to print a hexagon like this. So you can figure out the pattern from the given examples. And we want the shape to be positioned so that there's no white space to the left of the leftmost vertex. So essentially, there shouldn't be white space to the left of this guy. So there need to be white space here. So this is what we want you to print. And I strongly encourage you to try to code this first before you continue with the video. And yes. And if you don't use functions, which we're going to cover here, you're probably going to feel the code is very tedious. So you'll be writing large chunk of code that are similar to large chunk of code you've written before. And this is the time to use functions. So you are not writing code that are exactly the same, but they are sort of they have the same structure. It's just that the number of times things repeat are different, and so on and so forth. So these things you can write functions to avoid repeating the same code again and again. So here is a function to print one line. The intention is to print one line according to some specification. And the reason we use this particular way to specify a line is if we look at the figure, we realize a lot of the lines, it starts with some number of white space and then followed by this plus if it's a first line, or it followed by this, and then it's after that it's some number of another kind of character, and then there's the third kind of character. So each line, the lines differ by what character to start, what character use in the middle. So the first line and last line use minus sign, and the middle lines using white space, and what character to end the line. So start, middle, end, 3 characters, and also how many leading white spaces and how many middle characters that we are going to print out. So there's this each line can be specified by giving this 5 pieces of information. So what this function does is it uses 5 pieces of information and print it out. So it will first print n1 leading white spaces, and then it print the character first, and then it print n2 copy of the middle character, and then it print 1 copy of the last character and new line. So after writing a function, then the rest of the code for computing hexagon become much more succinct. So after reading in n, we first print the top row using this 5 specification, and then we print the part between the top row and the middle row, because the top row and middle row, basically these lines, they start with slash and end with the backslash, and have white space in the middle. So we have a loop. I goes from I to from 1 to n-1. Print these lines, and then we print the middle row. So the middle row start and end with a plus sign, and it has a 0 leading white space. And then we print the part between middle row and bottom row, and then we print the bottom row. So with such a function, it make the code more succinct. It also make it easier to understand. So how exactly does this function work? So this is a function definition, and it has 5 arguments. So it takes 5 sort of input value into the function, and then it does things. And each of the input value have a particular type. So here we use the red thing for the argument. And this is a function body, this is the printing first line, and so on. Now when we call the function, we write the function call. So by the way, the function should be first defined before we call it. So we should put the print line function before the main function. So this is a function called, the thing here used here are called actual arguments. So in fact here, these are for, I think, called formal argument. But the intuition is we also need to have 5 things here which are matching the 5 arguments here. And each of these things here should be an expression. So here is sort of like a variable declaration that has a type and variable name. Here should be expressions. And a function call, we will first evaluate the expression in the actual argument. So assuming that n is 4, then these function call essentially become equivalent to this function call. So 4 and 4 minus 1 times 9. And these function call can be conceptually viewed as we create a new block, and then we have a whole bunch of assignment statement. So n1 is assigned 4, first is assigned plus, n2 assigned 9, and so on. After we do all this assignment, and then we execute the body of the function. So that's one way to look at it. That's not how it works, because the function actually can call itself, which is known as recursion. So then that, but without recursion, we can view this is roughly what how it works. This line is replaced by this assignment of these expressions to the formal argument, and then execute the body of the function.